Okay, so we're in Publisher and we're looking at the electrical circuit midterm question. Question number 1, the top one, was a parallel circuit, and it has a 9-volt battery attached to a 330 ohm resistor, and then the branch 1 of the parallel circuit has an LED light that has 10 ohms of resistance. Goes around a big circle. There's your first circuit, and then your second branch goes over here to an LED that has 100 ohm resistance. Maybe it has a different color value or something, and it gives off 100 ohms of resistance. So you basically have 2 circuits here, and you have to answer these few questions. So there are 5 questions. The first one is total current. How do you know what the total current of a parallel circuit is going to be? The second one asks you, what is the voltage at LED 1 and LED 2? The third one says, what's the voltage at R1? I'm pretty sure these are all going to be the same, and I think they're all going to be the total voltage because that's what Kirchhoff's law told you. And then what is the total resistance? We're going to figure that out by making, we're going to have to figure this out and this out by making a table. You can use the total resistance formula of the reciprocal of the reciprocals of the total currents, but you are better off going ahead and making a table. I think it's easier because not only will you get the total resistance out of the table, you'll also get the total current. Alright, so then the current branch at 1 needs to be calculated, and the current branch at 2 needs to be calculated. So we'll figure out what these things are doing and go from there. So the first thing I want you to do is I want you to make a table, and the table button is right up here, and you're going to tell it how many cells, and we need at least 4 down, and we need 4 across. Yeah, because the top cell is going to be used as a branch column header. So we have branch 1, B1, you can do R1, it doesn't matter, B2, and then you're going to do your totals over here. And then down here you're going to do your voltage, you can do your current, you can do your resistance. Alright, so now all we have to do is populate our table with information. Well, what do we know? We know these values across here for voltage because Kirchhoff says the voltage stays the same in a parallel circuit no matter where you are. So this is going to be 9 volts. That one's going to be 9 volts. And the total voltage is 9 volts. And that means that it doesn't matter where you're measuring. If you wanted to simulate this, you could do it on the circuit simulator, and you'd find 9 volts anywhere you measured across these or across those. And you'd have to do that with a voltmeter. We don't know the currents yet, so we've got to calculate the currents, and we'll do that later. But we do know that this branch right here has a certain amount of resistance in the branch. And so if you add this resistance and that resistance, you'll get the resistance for that branch. You'll get 340 ohms. To insert the symbol, you click on Insert, you click Symbol, and if it's not available for you right here, then you'll have to click on More Symbols and type in Greek. Find it. So you could type it in there. It's easiest for me if I just highlight this and just copy it and then paste it in my other values and then change it. Then I don't have to insert it again and again. So the branch 1 has 330 plus 10, which is 340. Branch 2 has 330 plus 100, so it is 430. And then branch, or the totals, we don't know. You can't just add this and that and put it here. That doesn't work out. So we're going to calculate that later. After we get this field put in, then we'll be able to use Ohm's law to calculate this field. Alright, so we do have enough to get started here. We can do the current of branch 1. So we can fill this question right here in by saying 9 volts divided by 340 ohms is equal to what? So we'll throw a little calculator up here. 9 divided by 340 is equal to 0.02647. So 0.0265, which rounds to 0.2027. So we can put that value right here, 0.027, and we are in amps. Do the same thing for this one. We're going to say 9 volts divided by 430. 0.0209, which is 0.021. 0.021 amps. Okay, so now we know that the total amperage is the addition of this plus that. So we take and we add this value plus 0.027. It's not exact, but it's close enough. 0.0479. So 0.048 will be fine. 0.048 amps. And that's 48 milliamps, that's 21 milliamps, and that's 27 milliamps. But we don't have to say that yet. We just need to put these values in here. So then the question becomes, what is the total resistance? All right, so we've got the answer for branch 1 of 0.027, for branch 2 of 0.021, and we've got the total current at 0.048 amps. And now we've got the, if we look here, branch 1 has 9 volts of electricity flowing through it, and branch 2 has 9 volts of electricity flowing through it. So no matter where you check on your parallel circuit, you're going to get 9 volts in your circuit. Then we go up here to your total resistance. Total resistance is 9 volts. Remember, resistance is voltage divided by current. 9 volts divided by 0.48. So you can see this is going to be a bigger number, whereas before it was a smaller number because we had the bigger number. Anyway, you'll see. 9 volts divided by 0.48 is equal to 18.75. I'm sorry, did I do that right? 9 volts divided by 0.048 is equal to 187.5. That sounds right. 187.5 ohms. So we have answered all of the questions in problem number 1.